Well, you thought you could go to your Google interview and not study word search. You'd think, hey, of course, there's some sort of search engine, so of course you would want to know how to search stuff. Except that when you go here, you find out what companies actually asked this question in the past, say, 6 months. You see that Google is not actually one of them. At least, not in the past 6 months. Okay, so they may get back to asking this question, which says, given an m by n grid of characters, that would be grid of characters, board and a string word, return true if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. There will be some test cases with a board or a word larger than constraints to test if your solution is using pruning. Okay. Well, not sure if that's relevant here. Okay. So you just need to find a particular word. In this case, it's ABCCED. We see that we found ABCCED over here like this. In this example, they ask you to find C, and you see it here. You see C, okay? In this example, they ask you to find ABCB. You have ABCE at all kinds of combinations, but no ABCB. Okay, how the hell do you go about doing this? Well, you can see this right here. You could see that you could just search letters just as you would do. You could go along the grid, and whenever you see the first letter of your word, you could just start searching in a depth first search and go through everything else. The problem here is what happens if you already did A and you go down to S, and then how do you tell it, don't go search A again? You just came from there. Well, that's where backtracking comes in. So you temporarily save the value of A as something else to indicate that you already searched it. And then you send S into whatever magic method you put in there, and S will now think that A has already been used up. But by the time your recursion comes back to A, then you know that you could put back the original character and start all over in some other direction. Okay, so that's how we're going to do this thing. Okay, the first thing that we're going to do is we're just going to do a little sanity check. So if, let's see now, if word is empty or board is empty, return false. Now, then we want to come up with a bool. Did we find the word? And we're going to set it by default to false. And at the end of the function, we're going to return found match. So this kind of syntax just means return whatever it is. If it's true or false, it'll return it. Now we're going to have to modify that by some sort of method. So we said we were going to iterate on the board, and this is how we do that. Classic int int I equals 0, I smaller than board.size I++, and we're going to have int j equals 0, j smaller than board 0 dot size, j++. So all we're doing is iterating through this thing. And so if we see that if board I j, so if we hit the first letter equals s of 0, if we hit that first letter, let's just mark that, hit first letter, then we know that we could use our little magic function here, which we're going to call search word. And how are we going to play this? We're going to send in the word. We're going to send in, well, we're going to be building our word, and so we're going to send in an empty word, and that would be the current word. That's how we're going to set this. We're going to send the board, whatever it is. We're going to send the current index. We're going to send I, J. And finally, we're going to send found match, which will be modified to whatever the value is if the word was actually found. And as we're iterating, if we already found the word, we don't want to continue iterating. So if found match, this is before it moves on to the next character. If found match, return found match. So if it's true, then we return it. So, okay, let's just make a little bit of space. Now let's write that. That search word little magic function here. So void search word. Okay, and we said we would throw in the word first. So now, just because LeetCode doesn't use this STD notation and so on, doesn't mean we're not going to. They also don't pass things by reference. We're not going to do that because we're cool. We said we would have our current word, so that's going on. Finally, we're going to send in the board, and again, we're going to use that. We're going to use that STD notation. After the board, we just want to pass in an index by value this time. Same as int I, int j. We could make those constant as well. Now we send in the found match by reference because we'll be modifying that. Okay, so we have let's see now. If our current word, this is our base case. If our current word dot size equals our search word dot size, then we could just return. But prior to returning, we send found match equals true, and then we return. Otherwise, okay, now we just do a little sanity check. So let's see how we play this. If x smaller than 0, or y smaller than 0, or I bigger or equal to board.size. So we're just checking the size of this thing, see how this goes. Or j bigger or equal to board 0 dot size. So that would be a column. Or what else do we have? Let's see now. Well, okay, if this letter over here does not correspond to, does not equal the word at the current index, or we've already found the match. So if somehow we already sent our search word in here before we actually returned, for whatever reason, and we're starting to run this thing, we might as well go back right away. Then we could return over here. That's all we have to do with that. So now that everything's been checked and we're at a correct cell within our grid, we could start playing around. So current word plus equal, so we're just going to increment the letter, word index. Now we're going to, now this is the kind of interesting part here. We want to set a temporary variable. So this is our temp character. What is it? This is our, yeah, this is our, what is it? this is our temporary character, and we want to set it to, let's see now, board. Um, yeah, why did I put X over here? This is actually I. That's what I'm looking at over here. So something was off there. I could see something was off. So we're dealing with I and J. So that's our temp character. Then we're going to set this to board equals, sorry, let's see now. Now we're going to set board I J equals something. And this something, actually, we're going to go back here. The reason why it's going to go, the reason why it's never going to find a space. As soon as this is not the same as word index, we're going to go back here. So it's going to return, and that's why this is a good character to put as a temporary character over here. And let's immediately, before we do anything else, just set this back to temp. Now is where our recursion comes in. So we could do our search word. Okay, so we send in word, we send in current word, we send in board, index, index plus 1. Then we have, okay, let's just write I, J, and then we have found match. Let's just copy this 3 more times. So we want I plus 1, I minus 1, J plus 1, J minus 1. So this corresponds to, I think I wrote something wrong here, I plus 1 over here. I think that's all we need. Let's see what happens if we run the code. So this is going in every direction, up, down, left, right. That's all it's doing. Let's see if this miraculously works. And LeetCode taking a strange amount of time. It does these little freezes every now and then. Let's see what happens if we select everything and do a little refresh. Come on, LeetCode, you could do it. And our survey says, what's its problem here? If board error undeclared of identifier S. Oh, it's word. Sorry. And did I do the same mistake here? No, it looks okay. Let's hit run code. Undeclared identifier Y. Again, I was using X and Y's, line 35. I, J, okay. Okay, that looks like it works. And now, we have a winner. Thanks for watching, everyone. Oh, wait a minute. That can't be. That looks a little slow there. Let's run that again. Okay. So I'm not sure what I did right there. Looks like in an iteration before, now it goes at 440 milliseconds. The exact same code that I was copying from has 80 milliseconds. What's up with that, LeetCode? Not sure. So, too bad. See you around, everyone. Complain to LeetCode. Have fun.